Hello, this is Dr. Henry, and today we are going to be looking at what's called limiting reactant. And let me get my pen going here. So what you're going to need to understand is what it means for a reactant to be limiting, and you're also going to have to recognize when a stoichiometry problem involves a limiting reactant. So we're going to show you the skills that you're going to get is how to identify the limiting reactant, how to do a Stoke problem with the limiting reactant, and then we'll also look at how you can figure out how much of the non-limiting reactants, or sometimes these are also called the excess reactants, are left over. So what happens when a chemical reaction runs out of something? Your car runs, it's a chemical reaction, you need gas for your car to run. What happens when you run out of gas? Your car stops. Well, same thing here, the reaction stops. So a reaction in which you run out of something is called a limiting reactant problem. And the limiting reactant problem, reactant or the limiting reagent is what you run out of. It limits how much of a product you can make. So let's look at an example. Let's look at this reaction. We have 6 cans of Coke plus the plastic ring makes one 6-pack. So what if you had 51 cans and you had 4 6-pack rings? What are you going to get out of this? And I think if you look at this, you can tell what are you going to run out of first? Probably the plastic rings, because you got a lot of cans and you've got a few rings. So there are 2 possibilities in this actually. You're going to use up all the cans first, or you're going to use up all the plastic rings first. So let's look at this. So if you have 51 cans, how many 6-pack rings do you need? You need 8.5. 8.5 times 6 is 51. And you would get 8.5 6-pack. All right, with 4 plastic rings down here, right? How many cans would you need for that? You would need 24, and you could make 4 6-pack rings, or 4 6-packs. So you're going to see this is the lower number. So we only have enough plastic rings to make 4 6-packs, and then we're going to run out of the rings, because we need 8.5 to use all the cans, but we only have 4. So the plastic rings are going to be our limiting reactant. So here are the steps for solving limiting reactant problems. And instead of me just reading these to you, you can just pause the video and you can read these over. And let's go ahead and look at an example problem. Given the following reaction, so we have 16 moles of copper plus 1 mole of sulfur produces 8 moles of copper 1 sulfide. Here's our problem. If we had 100.5 grams of copper and 235 grams of sulfur, how much copper 1 sulfide would we make? The first question is this a limiting reactant problem? And if we look at our steps to solving limiting reactant problems, step 1 says, does the problem give you amounts for more than one reactant? So let's look at the problem. We've got 100.5 grams of copper. We have 235 grams of sulfur. They're both reactants. So the answer to this is yes. So this is a limiting reactant problem. All right. Step 2, pick one of the reactants and then use stoichiometry to figure out how much of one of the products you can make if you use this reactant up. Now the key thing here is, look at this part right here, because this will save you some time if you pay attention now. If you're being asked to find out how much you could make of a specific product, make sure that you pick that product. Now in our reaction right here, copper 1 sulfide is the only product, so you've only got one choice. But you'll do some other stoichiometry problems where there's more than one product. So make sure you read the whole question, and if it asked you how much you can make of a certain product, pick that when you're doing number 2. So let's start with 100.5 grams of copper, And what we're going to do is we're going to convert grams of copper to grams of copper 1 sulfide. And this is a gram to gram problem. And I'm assuming that you can do a gram to gram problem. And if you can't, you need to go back and look at your notes or some videos on that and get some help. So we have 100.5 grams of copper. In 1 mole of copper, there's 63.55 grams of copper. Looking at the coefficients, for every 16 moles of copper, we have 8 moles of copper 1 sulfide. In 1 mole of copper sulfide, there's 159.16 grams of copper sulfide. So we get an answer of 125.8 grams of copper sulfide. So if all the copper reacts, we will produce, I've lost my pen, we will produce, right, 125.8 grams of copper sulfide. Now let's look at the other reactant. All right, step 3, do the same for each of the other reactants. So we're going to start with 235 grams of sulfur. In 1 mole of sulfur, there's 256.48 grams of sulfur. Looking at the reaction, for every 1 mole of sulfur, we get 8 moles of copper sulfide. And then you could look at the other problem to get this answer. 1 mole of copper sulfide is 159.16 grams of copper sulfide. So we end up with 11,060 grams of copper 1 sulfide. Now, the reactant that can make the least amount of product gets used up first, so it is the limiting reactant. So if you look at this, here we have this reactant produces the smallest amount of copper sulfide, 125.8 versus 1,160 grams. So this is how much copper sulfide we can produce, but the question is, what is the limiting reactant? So you got to go back. So copper is the limiting reactant. All right, make sure you don't identify copper 1 sulfide as the limiting reactant. That's the product. And we figure out which one is the limiting reactant because sorry, someone knocked at the door. I got distracted. So figure out which reactant makes the least amount of product. That's your limiting reactant. So copper is our limiting reactant. All right, now, how much of the non-limiting reactant would be left over? So copper was our limiting reactant. That means sulfur was in excess. So if the problem asks how much of one of the other reactants is left over, then start with the grams of product that you can make from the limiting reactant, and then use stoichiometry to figure out how much of this reactant would get used up, and subtract this amount from the number of grams that you started with. And you can see I didn't do, my PowerPoint's kind of messed up because the answer's already there, but let's do this. So we knew that because copper is the limiting reactant, we get 125.8 grams of copper sulfide. So let's convert grams of copper sulfide to grams of sulfur. So 125.8 grams of copper sulfide, and 1 mole of copper sulfide, there's 159.165 grams. For every 8 moles of copper sulfide, there's 1 mole of sulfur, and 1 mole of sulfur, there's 256.56 grams of sulfur. So in order to produce 125.8 grams of copper sulfide, we need 25.34 grams of sulfur. We started with, all right, 235 grams of sulfur. We need 25.34 for the reaction, so you subtract those two, and we have basically 210 grams of sulfur left over. So follow the steps. If you can do a gram to gram problem and you follow these steps, you will be able to do limiting reactant problems. If you need help, please look at the website or ask me for help before school, after school, or during lunch. Thank you.